All right. Hello, my name is Jake Goldberg, and we're gonna be doing project one.
My name is Kenneth Behar. We're doing project one, which is an analysis into basic simulations of co-et Poiseuille and a hybrid of the two flows.
Yeah. So we're gonna start off by just setting up the mesh, and then I'll hand it off to Kenneth once we get to the setup portion to do Poiseuille flow. And then we'll switch to me to do co-et flow, and then we'll switch back to Kenneth for hybrid flow. So to get started, you're gonna open up Workbench. We already have it open, so what you're gonna do is you're gonna go to the right side here and look for fluent. Make sure this little thing pops up. Then you're gonna right click on geometry, and you have multiple different options. And what we're gonna do is we're gonna use space claim because yeah,
It works.
it works. It does the job. Type. All right, we just gotta wait for it to load. Let me try it again. Oh, it's starting at the bottom. Oh, on the bottom left, you can see what's going on. Forgot about that. There we go. All right, so now that we're in space claim, we're gonna make it a little bigger so I can see. All right, so we're gonna choose a sketch plane. We're gonna do X, Y. We're gonna look at the plane, obviously. Make a rectangle, boom. Click on the origin, make sure it's on the XY plane for easier, And then we're gonna do 3,000 length, and then we're gonna do 20 on the height. All right. So we're gonna go like that, make sure it looks pretty good. And then we're gonna click on End Sketch Editing at the top. All right, then we're gonna minimize that. We're gonna go back here, and what we're gonna do is we're gonna right click on Mesh, go to Edit. All right. Just gotta wait for everything to load real quick. All right, now everything is loaded. What we're gonna do is we're gonna go over to Mesh. We're gonna right click, go to Insert. We're gonna insert a method. We're gonna select the main body diameter geometry. After click geometry first, and you're gonna click the main body geometry and click Apply. Then you're going to go to Method. You're gonna go to Triangles, and what you're gonna do is gonna change element order to quadratic. Nice. So then we're gonna go and click on Generate. To generate the mesh. And then after the mesh generates, we're going to zoom in and we're going to select the bottom wall. After selecting the edge tool, we're going to right click. We're going to go to create name selection and we're going to name it wall underscore bottom. Then we're going to click on the top wall and we're going to do create name selection again, wall underscore top. All right. We're going to zoom out. We're going to go and zoom into the inlet side now, which could be any side, but for us, it's going to be this one. We're going to do create name selection and make sure you name the inlet so it's automatically recognized inside of Fluent. Very good. We're going to repeat the same thing for the outlet. Create name selection, outlet. Okay. And let it load. All right. Then we're going to go back to mesh. We're going to go to insert and click on sizing. So for geometry, we're going to click on the lower and the topper wall, the upper wall. And element size, we're going to put at 0.001 for millimeters. And my geometry didn't save, so we're going to go back and do that again. We're going to click on the bottom, click on the top, and then we're going to click apply. And then element size, like I said, is going to be 1 millimeter. Yep. And then we're going to go back to mesh and we're going to click element size. We're going to change to 0.01 or 0015. Oops, sorry, I mistyped. 0.015. So we get 15 millimeters. And then we're going to go to statistics and just monitor the mesh it's created. So now we just have to wait for the mesh to generate. Okay, now the mesh generator, we're going to go down here and make sure that only counts less than the amount that the student version can run. And then we're going to minimize. We're going to go back to mesh. We're going to right click and go to update. We're going to wait for the green check to pop up. All right, now we're going to double click on setup, and this is going to take us into Fluent, and Kenneth's going to take over.
All right, we gotta make sure it's in 2D. It's locked into 2D, so we're perfect over there. Low precision and go up to 4 cores, as that's what student will allow us to do to have the most amount of power for this. Take a second to load. And perfect. Take a little bit more time. All right, starting up. It's taking a little bit more time to fully load in. And perfect. All right, I'm going to go to models. Going to go to viscosity and change it to K epsilon. To that's good there. Go to our material, our fluid. Going to make this air a little bit thicker, no, a little bit thicker by upping the viscosity. Change that. I'm going to leave our density the same as well. Go there, minimize fluids, to our boundary conditions. And as this is our inlet on the Poiseuille flow, we are going to have 8 meter per second velocity. And that's good there. All right, so get our reference values to ensure that everything looks the same as what you put in from the inlet, and it has everything. So that's good over there. Now we can go to run calculation, put in our number of iterations. I'm going to do 1,000 to ensure that has more than enough space to do what it needs. I'm going to press initialize and calculate.
As you can see on the screen, it's converging. So you can use that to tell how many iterations that you'll need for future runs.
And it is done. Now we're going to go to our graphics, pick our contour. It's going to be a velocity contour for this, to magnitude, join everything we have, and have it display. Take a second to load. And awesome. See that everything is flowing in a convert, and they have the most amount of flow in the center as well for our graph. Go over to results. Second to load in. And go to location. Line 1 is going to be our midpoint. You see our flow in the center, and then line 2 will be our endpoint. All right, I forgot to change it on the data on the midpoint. So I'll just do it first here. The endpoint we're going to do near the end to ensure we get simulation of essentially the end. If you do it at the end, it can make your data a little bit less. Do 0 on the bottom and on the do 0 on the top and 20 millimeters the height of it over there. Apply. You see the little bar right over there. The line for the midpoint. Going to do it at the midpoint, so we can do 1.5 and 1.5 meters exactly, and then 20 millimeters high. And there we go. So you can see we have our endpoint and our midpoint over there. We can make a chart that will show us what we need. Show the velocity at the midpoint and the endpoint. So have midpoint over here. That'll be located at the midpoint. Series 2 is going to be our endpoint. That is located. Oh, okay, a second. Yeah. All right. Wonderful. So sorry about that. All right, that should not be happening with that. General XY data series there. Oh, I forgot to change this. Okay, yeah, we're gonna have velocity U on the X and Y over there. Apply and perfect. So you can see that our velocity is highest at the center at the end, a little bit less at the midpoint, and perfect over here. So we're gonna exit out of that. And we're going to go back into setup to go over the co-ed flow.
I'll take over. So for co-ed flow, what we're going to do is we're going to go to materials, keep air exactly the same. Then we're going to go to make sure that the inlet velocity is set to 0 and change to a pressure inlet. And we could do that by double clicking on it. Excuse me, boundary conditions, double click on boundary conditions. We'll click on inlet and we'll go from type to velocity to type pressure inlet. All right, let it load and then make sure the total gauge pressure is 0. Apply. All right, now what we're going to do is we're going to go to the wall and we're going to go to the top wall. Right click on, or excuse me, double click on it. We're going to click on under wall motion. We're going to go to moving wall. And we're going to set the speed to 8 meters per second. And no slip condition. And we're going to leave everything else standard. We're going to click apply. We're going to close. We're going to go to reference values just to make sure, double check. Inlet, pressure 0, velocity 0. So we're good to go. So then we're going to go over here to run calculation and click or right click on it after we make sure that our iterations are to 1,000. And then we're going to click initialize and calculate. And we're just going to wait until it converges. Converged. Now just give it a second to load. And here we can see the co-ed flow, a linear velocity. So now what we're going to do, since that checks out, we're going to go over here to the results, make sure it's updated. Give it a second. All right, we're going to double click on it, wait for it to load. Give it a second. All right, then we're going to go to the chart. And we can see that as a linear velocity graph from X or from Y equals 0 to Y equals 20 millimeters. So now what we're going to do is we're going to minimize that. We're going to go back to fluent, and then Kenneth's going to walk you through hybrid flow.
The hybrid flow, it's mostly the very little we have to change now. We are going to go back to our boundary conditions over here. If it will load. Awesome. Going to go into the inlet. We're going to change it back to a velocity inlet. I'm gonna go into our velocity and we're gonna change it to 8 meters per second. We can go to our boundary conditions again and go into our top wall and ensure it is going to be moving at 8 meters per second. Apply that, close it. Everything go to reference values. All right, so we have got to go again to inlet, 8 meters per second, 0 pressure. Everything looks good. Correct viscosity. And now we can go to initialize and calculate. Perfect. All right. That's looking pretty good. We have the plate moving as well. Velocity slow here and getting faster the more it goes up closer to the moving plate and the speed of the inlet. See that with the contour, and also add vectors based on the velocity. Show all of it, save and display, and I can see the motion of it as well going forward. If we go over to the graph for it, update the graph. We can see that it has a hybrid flow where it exponentially gets faster and also interacts with the moving plate up top. And that is the demonstration of the Poiseuille flow, co-ed flow, and a hybrid of both of the flows. Thank you.